Hi guys, this is Mrs. Rhodes. I'm doing week 5, lesson 4, Friday's lesson here in the video. And so this is more function operations. Yesterday we went over how to add, subtract, multiply, and divide functions. And now we're going to go ahead and do some more practice. So what we want to start with is looking at all our functions. It looks like I have an f, a g, an h, a k, and a j, and I need to talk about their domains. So the first domain of f of x is going to be all real numbers because f of x is y equals 3, which is a horizontal line at 1, 2, 3. It looks like that, and that's our graph. A lot of times, if you're good at graphing especially, it's good to graph these. So for example, the square root of x minus 2 is a horizontal shift to positive 2, and the graph would look like this. Therefore, I can see that the domain is going to be from 2 to infinity. Or you can just realize that under any square root sign, you can't have a negative. So x minus 2 has to be greater than or equal to 0. So if I add 2 to both sides, x is going to be greater than or equal to 2, which is 2 to infinity for my domain. Or you could write it in inequality sign as x is greater than or equal to 2. It's your choice. All right, the next graph right here, I'll do it in a different color, is a parabola. It looks to me like, it's got two zeros, but basically it doesn't matter because the domain of any parabola is all reals. So, and when I say two zeros, I mean two x-intercepts, which is fine. I was just thinking about this graph. And then this happens to be a line, so I know that that's all real numbers. And then this is the absolute value of x, so that's all real numbers. So the only function we have right now that has an issue is this square root function. So the first thing we're a compound function we're asking is it says simplify the compound function, meaning come up with the equation of the compound function. This is g minus f. G happens to be the square root of x minus 2, then minus f. F is 3. So that's exactly what that function is. So g minus f of x is equal to the square root of x minus 2 minus 3. So it says find the domain of the compound function. Now the rule is you have to accept the most restrictive domain. The domain for g is 2 to infinity. The domain for 3, or for f, is all reals. Well, between these two, between the g domain and the domain for f, this one, g's, is more restrictive, so I have to accept that. So this is my domain of my compound function. This is the compound function, and the domain of the compound function is 2 to infinity. Now it says find g minus f. Well, when I go ahead and I get g minus f of 4, so you can go ahead and just plug in 4 for x into the compound function. So, okay, sorry about that. So you plug in 4 into, you could either plug in 4 into each one, or you can just plug it into the compound function, which I'm going to do. So this is going to be the square root of 4 minus 2 with a minus 3. So that's the square root of 2 minus 3. And I'm just going to leave it like that. Square root of 2 is 1.414, but we can just leave it like that. That's fine. So that's going to be my answer. All right, g minus f, I'm going to go ahead and leave, j minus f, I'm going to leave that one for you guys to do on your own. K times g. K is, and g. All right, this one's interesting. So K is going to be, I don't know why my computer's freaking out, is going to be a negative 2x plus 1. And that's going to be times the square root of x minus 2. And basically what this means is you're just going to do the distributive property of this times that. So it's going to be a negative 2x times the square root of x minus 2. And now I'm going to distribute the 1 plus 1, and 1, I don't have to write that, of x minus 2. So, and that's just what it is. That's my function. So that's my compound function. Now, once again, to get the domain of this, you take the most restrictive domain. Okay, I just wrote take most restrictive domain. That's important. So out of these two, K and G, it was G that had the most restrictive domain. So I'm going to accept that domain. And it makes sense. Like, I'm not allowed to put a negative number underneath here. So 2 is the lowest X value I can put in there. If I put in 1 or 0 or any negative number, I'd have a negative underneath the square root. Now it says K times G of 9. So I'm just going to put that in. That's negative 2 times 9 times the square root of 9 minus 2 plus the square root of 9 minus 2. Erase this. That's going to be negative 18 times the square root of 7 plus the square root of 7. And actually, you can add this. This is negative 18 square root 7 plus 1 square root 7. You can add those together. This is going to equal negative 17, because negative 18 plus 1 is negative 17 times the square root of 7. And that's the answer. Okay. Now division. Division is really important because division brings up a whole nother issue. F over K. So that's going to be 3 over, because that's F, over K is negative 2x plus 1. That's the function. All right, we're done. Now it says, what's the domain? So originally I'd said take the most restrictive domain. Well, this F has all real numbers and K has all real numbers. So the most restricted domain is nothing. I mean, they're both all real numbers. But division always poses a problem. You can never let the bottom equal 0. So I have to set negative 2x plus 1 and say can never equal 0. So negative 2x can never equal negative 1. So x can never equal 1/2. So now my domain for this function is going to be all real numbers, but x cannot equal 1/2, because that's the value that would make a 0 in the denominator. If I plug in 15, that's still going to have a 3 on the top, and it's negative 2 times 15 plus 1. So that's 3 over negative 30 plus 1. So that's going to be a negative 29, and that's my answer. Okay, I have multiplication next and 2 divisions. I'm going to leave the multiplication for you guys. That's a good one to multiply, H and K. That's a good big distributive property. I'm going to go down here. It says answer the following using the table to the right. This is good practice for you for next year. You're going to have to use tables like this next year in calculus class, if you're taking calculus next year. Some of you will not be. If you're graduating, or maybe you will next, in the following year in college. But either way, let's look at this. So we have, these are the X values right here. And then this is Y values for the F graph. This is Y values for the G graph. So this says F of 0 plus G of 0. So that's basically, I have to find out what F of 0 is. So F of X answer when X is 0 is 5. So this is equal to 5. And G of 0 is equal to 0. So since I'm adding, this is 5 plus 0. So F of 0 is 5, and G of 0 is 0, so the answer is 5. I'm going to do a division one. G divided by F. You guys are going to do the rest, but G divided by F of 3. So I want G of 3 first. Here's the X value of 3. G of 3 is negative 2. F of 3 is going to be equal to 3. So now this is saying take G and divide by F. So I need to do, for this one, I'm going to have a negative 2 divided by a 3, and that's going to be my answer, negative 2/3. All right, so those of you watching this video, I'm going to have you go ahead and finish this worksheet, and you will be submitting it.